So once we get the right paddle, we think, oh, well, let's duplicate that to the left paddle. That is very true, but I always like to make sure that when I'm coding that I get every interaction with, say, this paddle done before I duplicate it and change it up the commands for the left paddle. And what is the last thing I need to do with this paddle? Well, I need to limit and make sure it stays inside of our scene. To do this, we need to set some limits, and we're going to set some limits using our transform and our position, and specifically the Y position. So what you need to get is you need to figure out what your upper and lower bounds are, basically, or limits in your scene. And to do that, I'm going to select this paddle, go to the Move tool, just because I can grab an axis, or this tool up here, or the W key, and I'm going to move it to the top like this, and then I'm going to note what my Y value is. My Y value is 3.49. In my case, I'm going to round up to 3.5. Okay, and I'm also going to reference it down here as well, just to double check, because I think it should be the exact opposite, or the negative version, which it is, negative 3.52, so close enough to a negative 3.5 exactly. So that's my limits. So think about it. How do I want to use these limits? Well, as I'm going up, so like in the middle here, I'm at 2.56. Think about the correlation between 3.5 and 2.56. 2.56 is less than, okay? So what that means is as I'm moving up, I want to make sure that I am always less than 3.5. And when you come down here and you think about it, what is, say, 0, or what is, say, negative 2.79 compared to negative 3.5? Well, because it's negative, even though it's looks like appear to be a smaller number, 0 or negative 2 something is actually greater than, larger, because it's not less than 3.5. So going down, I need to make sure I am greater than negative 3.5, and going up, I need to make sure I'm less than positive 3.5. So let's go over to our script and add that in. So where do we add that in? Well, I could do another if statement in here, or since I know it has to be both input.getKey up and the position has to be less than or greater than, I'm going to add it just in the same if statement, right? Because I can check multiple things. So this last parentheses here is to encapsulate this parentheses here. So this is my entire if statement parentheses. So I'm going to go inside this last one here, and I'm going to hit space just to make it look nice. And I'm going to go shift and hit the double and sign, or the 7 key at the top, because that's my and command. So saying input.getKey up, and I've got to do something else. What's my something else? Well, I need to make sure the transform.position.y, I want to make sure that is less than 3.5 going up. Okay, and all I'm accessing right over here in Unity is the transform.position dot specifically the Y value. That's how that coding works. All right, and I need to do that for the down. So come in here and transform.position.y, and what was it I needed to make it? I needed to make it greater than negative 3.5. Come over here, make sure, save it, and make sure in Unity that I don't have any errors. Hit play, and look, now you can see in my scene over here that my paddle is not moving at all. So we got our right paddle working. Now we need to, and everything should be good here. The thing I will note is 3.5 is my limit to my version of the game here. If your version of the game, the paddle sizes might be different. You need to make note of your own reference spacing. But mine was 3.5. So let's talk about how we can copy this over. There's multiple ways. I could very easily right-click, create a new C# script, and you could just copy this whole void update, or actually just take and copy this. Or we can also, into right paddle here, do a Command D duplicate, and then I have it duplicate to the name right paddle 1, well, I need to click on the word of the name and change it to left paddle. And if I open up left paddle, then notice, though, our public class is off because it's used to what the right paddle was. And remember, as noted, left paddle is the name of the file, so you have to have the public class left paddle be the same name as the file. So that's first step, change that. And then the only things left to do is figure out what keys do you want for the left paddle to use. Well, in our case, I'm going to use W for up and S for down. I'm going to do Command S to save. I'm going to pop over to Unity. You get this error saying the global namespace is our right paddle is already used. That's because we had the public class right paddle twice. Then simply click the paddle 1, add it to the left paddle. If you don't remember what your speed is, you might have to click to your other paddle. I remembered mine. I changed to 10. Hit play. Make sure both up arrow and down arrow work for the right paddle still, and W and S now works for the left paddle. All right, so that's the paddle movement. Let's get the ball bouncing around and moving real quick. To do this, your ball should already have a circle collider, and it should already have a rigid body. And with the rigid body, we should have set the gravity scale to 0. Now, we're going to use our rigid body and the collider to bounce back and forth between the paddles. So I need a new script to start doing this, so I'm going to create a new C# script, and I'm going to name it ball. I'm going to double-click ball, open it up. So with our ball script, we're going to be able to use the rigid body to set a velocity of some kind using a speed variable and setting up initial movement. And from there, we'll eventually code other movement later on. So I actually need two variables at the top. I'm first going to use a public float speed variable again, except remember this speed variable is only local to this script, so it's not like the other speed variable on the paddle. Those are separate values. And then I also need a private rigid body 2D reference, and I'm going to name the variable RB. Now, rigid body 2D, and the reason it's private is because we're just accessing our rigid body component that's on the ball, and we can't just directly access it by saying rigid body 2D dot and then do something. We actually have to have a variable of it, and then we actually have to connect the rigid body to our RB variable, which we'll do here in a second. But that's how kind of Unity works. You have this script, which is a separate object. You have a rigid body, which is a separate object. To get the script to talk to the rigid body, you have to get what they call a reference to it, so that you can start calling functions on it or accessing variables that the rigid body has and stuff like that. So to get the ball moving, I need to go to the void start method. The void start method is our initializer. So what are we going to initialize? Well, the RB variable, we need to get component rigid body 2D. It should start autofilling it for us. Parentheses, semicolon. So this get component.rigidbody2D with the parentheses allows us to now just use the RB variable instead of using this command for get component every time. And then since I have the reference to RB, I just need to I'm going to access the velocity variable, and I'm going to set it to a vector2.right, and I'm going to take it times speed, and then save it. And that's it for this right now. So save it, go back to Unity, make sure we have no errors down here, go to the ball, attach the ball script. Speed is set to 10, hit play, let's see if our ball moves. And as you can see, our ball does just that, it moves to the right. Now, it doesn't do any bouncing or anything, so let's set that up real quick. I need a material, specifically a physics material, to connect to our ball. So I'm going to right-click on Assets for now, and towards the bottom of the list, you'll find Physics Material 2D. Select one of those. It has you pop up a new physics material. I'm going to call this Bouncy. or you could call it ball, whatever you want. And what you need to do then is in the inspector, we have our bouncy and we have two little simple properties. We have friction and bounciness. Well, I don't want any friction, so I'm going to zero that out. And bounciness, I'm going to set to 1. I want max bounciness. Now you could go above and I could say 5 for bounciness, but usually 1 is good enough for the bounciness because it usually ranges from 0 to 1 as these values. So what do I do with this bouncy material? So if you select the ball, you'll actually go, if you come over to both the collider and the rigid body, you'll notice they both actually have these material properties, and they're both set to none, needing a physics material 2D. Well, you could put it on either one, but in our case, I'm going to put it on the rigid body because it acts a little bit smoother with keeping the same velocity speed. So you can do two things. We can simply drag it over. So if I click and drag it and it goes blue or highlights so that it knows you're now attaching the bouncy material. Or I can click this little circle and switch from scene to assets and select the bouncy material. Okay, so there's two ways you can attach those things. So once you attach that bouncy material, you can hit play and you'll notice your ball now bounces back and forth. And if I move the paddle out of the way, it bounces, right? Now, the only thing is, which we will address in the next video, is how do I get the ball to move at different angles and things like that. But that's it. So simple paddle movement and getting the ball using the rigid body physics component to do most of the work for us.